Okay, for the following exercise, graph y equals x squared on the given viewing window. Determine the corresponding range in the viewing window. Show the graph. So the domain is supposed to be from -10 to 10. What's the range? Well, you have to evaluate it. You have to first of all realize that this is a parabola which opens upward. Okay. How do you know it opens upward? Because the leading coefficient on the quadratic function is positive. It's a positive x squared. Y equals positive x squared. Okay. So if it were negative x squared, it would open downward. So the leading coefficient on the quadratic will tell you whether it opens upward or downward. Okay. So if you had y equals, say, 2x squared plus 3x plus 1, that opens upward because 2x squared, that's a positive 2. The leading coefficient is positive. If it was negative 2x squared plus 3x plus 1, it would open downward because the leading coefficient is a negative 2. It's negative, so it opens downward. That's a nice little trick you can use. So the lowest point, since it opens upwards, the lowest point is going to be at the vertex of the parabola, or the very bottom of it, the very bottom. That would be where y equals 0 when x equals 0. Okay, so you know that's going to be the bottom point of your range. The lowest point of your range is going to be 0. So now to get the maximum value, or the high value for the range, you want to evaluate the function at the endpoints. In this case, it turns out to be the same. In other words, the endpoints of the domain are -10 and 10, right? So you evaluate the function at the left endpoint, -10, that's y of -10. You square that. Y equals x squared, right? So you square -10 and you get 100. And also y of 10 is 10 squared, which also equals 100. So the range is going to be 0 to 100, all right? So you can, if you want to see more of the graph, you can use a range from, let's say, instead of 0 to 100, go from -10 to 110, all right? So you've got the left and right endpoints, -10 to 10, that's your domain. Your range, you could say, is -10 to 110, and that way you won't cut off any, or just barely get the edge of the graph. Okay, so I have graphed this with my computer, and you're probably using a graphing calculator. So I'm just going to show it to you on my my printout here, which will be a lot faster than putting it on this board and a lot more accurate. So I put the viewing window that we talked about on this computer, and I got this result here. Oops, let's see if I can get that straight. There's your result, okay? Okay, number 79. It says graph y equals x cubed in the given viewing window, and then determine the corresponding range for each viewing window. Show each graph. So we have a domain from -0.1 to 0.1, closed interval. All right. This, by the way, you can see on page 16 in your toolkit functions, the cube function, y equals x cubed. So let's find out the range. Evaluate the function at the endpoints of this domain. You've got y of -0.1. That equals -0.1 cubed. You can punch that into a calculator if you want. That's -0.001. And then we also evaluate the right endpoint, y of 0.1. equals 0.1 cubed, and that's 0.001. So the viewing window that we have would be negative 0.1 to 0.1 as the domain, and the range would be negative 0.001 to positive 0.001. Okay. And so here it is on my printout. Okay, number 81. We have negative 100 to 100, and we want to evaluate y equals x cubed with those endpoints and the domain. So what's the range? You just evaluate the left and right endpoints, and let's try that. Y of negative 100 that equals negative 100 cubed, which equals negative 1 million. And then the right endpoint, y of 100 is equal to 100 cubed. And that's 1 million. Okay, so the range is from negative 1 million to 1 million. And so what does that look like when we graph it? So on my computer printout, here we go. Okay, number 83. Graph y equals square root of x and determine the range. So we have a domain of 0 to 100. Now square root of x is on page 17 in your toolkit functions. Alright, so 0 to 100, what's the range? So we can evaluate the function at the endpoints to find the range. Y of 0 is square root of 0, which is 0. And y of 100 is square root of 100, and that's 10. So the range goes from 0 to 10. And then when we graph it, we get this result. Okay, number 85. We have y equals cube root of x, and we're given this domain negative 0.001 to 0.001. Closed interval. So this function is shown on page 17 in your toolkit functions. So to find the range, you evaluate the function at the endpoints of this domain here. Y of negative 0.001. That equals the cube root of negative 0.001. To get the cube root on your calculator, use the fractional exponent. Cube root would be the same as 1/3 power. All right, so you can use 1/3 power on your calculator, and that's going to be negative 0.1. And then y of 0.001, I think you can guess what this is, because it'll be the same as the previous answer except positive. So the range is from negative 0.1 to 0.1. This cap doesn't like to stay on the pen. Alright, so here we go. Here's the result. Number 87, again using y equals cube root of x. Now we've got a domain from negative 1,000,000 to 1,000,000. And let's evaluate these endpoints to find the range. So y of negative 1,000,000 is the cube root of negative 1,000,000. On your calculator you can put to the 1/3 power, negative 1,000,000 to the 1/3 power, and that's equal to negative 100. And of course y of 1,000,000 is the cube root of 1,000,000, and that's 100. Okay, so the domain, or rather the range, goes from negative 100 to 100. And so here's the result. Okay, number 89. The number of cubic yards of dirt, capital D, needed to cover a garden with area small a square feet is given by D equals G of A. Okay, part A. A garden with area of 5,000 square feet requires 50 cubic yards of dirt. Express this information in terms of the function G. Okay, so the amount, or the number of cubic yards of dirt is D, and here it's given as 50 cubic yards. So we have D equals G of A, so here D is equal to 50 cubic yards. And that's equal to G of A, which is A square feet. That's the area. And the area is 5,000 square feet. So 50 cubic yards equals G of 5,000 square feet. Okay, or leaving off the units, 50 equals G of 5,000. All right. I don't know why this thing is crying. It must be sad about something. I don't know. Anyway, let's go to part B. So, well, we've done part A. It says express this information in terms of the function G. So that's what we've done. We've expressed that information in terms of G, using G in other words, all right, in the expression. So part B, explain the meaning of the statement G of 100 equals 1. What does that mean? G of 100 equals 1. Another way to put it would be 1 equals G of 100. Same thing, right? So, well, written this way, it's pretty easy. Just compare it with this, right? The 1 is capital D. So, and the 100 would be small 8, right? So, that means a garden with area 100 square feet requires 1 cubic yard of dirt. All right? There you go. Okay, last problem. Hooray! Number 91. Let h of t be the height above ground in feet of a rocket t seconds after launching. So you launch your rocket, t seconds go by, and h of t will give you the height of that rocket at that particular time. Okay, so explain the meaning of each statement. Part A. H of 1 equals 200. So again, t is 1, and h is the height above ground in feet. H of 1 is 200. So the height of the rocket 1 second after launch is 200 feet. All right. Part B. H of 2 is 350. So here t equals 2 seconds. So 2 seconds after launch, what's h? H of 2, in other words, 350. That's 350 feet. So the rocket has reached 350 feet high 2 seconds after it's been launched. All right, well, that wraps up this assignment. So go get some coffee, take a nap, whatever. Walk your dog, your cat. Play with your cat. Have fun. And I'll see you in the next section. All right? Later.